Hello students, welcome back to my YouTube channel. This is Kashima Soni and next topic in the series carboxylic acid derivatives, and we have discussed the first part in the chemical properties of the acid chloride. Today I am going to upload the chemical properties only, that is part 2 of the same. Okay, so if you have not seen any of the videos in carboxylic acid derivatives series, I will mention the link in the description box. Go over there, check them first and then come to this section, okay, for your better understanding. For a better concept clarity, you have to see the previous videos, then only switch to this part of the section. Okay, so proceeding further, because without wasting any more time, so now we are going to take up the chemical properties of acid chlorides only, and we have discussed monolysis, hydrolysis and alcoholysis as well, and reaction with your carboxylic acid. This is what we were discussing in the previous video. So far we have discussed till now, and where I have told you that your acid chloride will be reacting with acetic acid in the presence of base, and it leads to the formation of your anhydride like that. So what is happening? Your acid chloride being more reactive, I have told you in the interconversion part only that acid chloride is the most reactive acid derivative, okay, which is why it can get reduced to and it can get not reduced, it can get converted to the other least reactive, least reactive acid derivatives, correct? So your most reactive acid derivative, that is acid chloride, is getting converted into least reactive acid derivative, that is your esters, amide and anhydride. Getting that? So far we have discussed till now. This part that I have not told you in the previous video. See, in this reaction you can see all the reaction that we have discussed so far can be regarded as acylation reactions. Since in all of these reactions what is happening, the H atom of water, alcohol, phenol, ammonia, amine and carboxylic acid, it is getting replaced by acyl group. Okay, which is why your acid chloride, it may be regarded as acylating reagents. Understanding that thing? I repeat, where in all of these reactions that we have discussed so far, your H atom is getting replaced by H atom of water, alcohol, phenol, ammonia, amine. They are getting replaced by acyl group. Understanding? Which is why your acid chloride regarded as your acylating reagent. Your acetyl chloride, you can see I have concluded, it can be mentioned as an acetylating reagent, and your benzoyl chloride can be mentioned as benzoylating reagent. That is another thing to remember. Okay. Proceeding to the next part that we are going to take up in this very video, that is other reactions of the acyl chloride. Okay, and this is quite important. Whatever we have discussed so far in the series of carboxylic acid derivative, all of that is important. And the chemical properties, that they are very important, because sometimes they used to ask you Sorten-Baumann reaction and other naming reactions directly only. So the first reaction that we are going to take up over here now is when your acid chloride gets reduced to aldehyde. That reaction is known as Rosenmund's reaction. See, when your acid chloride is getting reduced to aldehyde, that reaction is known as Rosenmund's reduction. Okay. So what is happening? Your acid chloride, they are readily reduced to aldehyde with H in the presence of palladium deposited over barium sulfate and partially poisoned by the addition of sulfur or quinolone as catalyst. So they can ask you about what is Rosenmund reduction and explain in detail and write its reaction as well. So what you have to mention first, when your acid chloride, they are readily reduced to aldehyde with hydrogen in the presence of palladium deposited over barium sulfate, and they are partially poisoned by the addition of sulfur or quinolone as catalyst. Okay, that is your Rosenmund's reduction. You can see over here the reaction. And what is the function of sulfur or quinolone over here is to reduce the activity of the catalyst to such an extent that reduction stops at aldehyde stage. Okay, so that reduction does not proceed further after the aldehyde. So this is the main function of your sulfur or quinolone, so to reduce the activity of the catalyst. Getting that point? So that is one thing, where your benzoyl chloride, you have seen the example reacting with the H2, that is hydrogen, in the presence of palladium and barium sulfate and sulfur and quinolone. Okay, and it results in the formation of aldehyde, that is benzaldehyde and HCl. So this is your reduction to aldehyde of your acid chloride. Okay, and this reaction is known as Rosenmund's reduction, and it is extremely useful since the reducible groups such as nitro, NO2, C double when present acid chloride are not reduced during this reaction. Okay, understanding that thing. So that is one thing over here that we have discussed about the Rosenbaum reduction, where your acid chlorides get reduced to your benzaldehyde. Okay, proceeding further in the same case, you can see a reduction of aldehyde, Rosenbaum's reduction. The example related to the same. Over here you can see where your para-nitrobenzoyl chloride reacting with hydrogen in the presence of palladium, barium sulfate and sulfur or quinidone acting as a catalyst, and what is happening, it gets reduced to para-nitrobenzaldehyde and HCl is removed as a side product, released as a side product. So this is another example where cinemoyl chloride is reacting with hydrogen and same reagents are used, and it leads to the formation of aldehyde like that, and HCl is released as a side product again. So another reaction that we are going to take up in the series, where you will see the reduction of your acid chloride to primary alcohols. Okay, that is the case. See, if you see the substrate like this, the palladium, barium sulfate and sulfur or quinidone, you are understanding that your acid chloride is going to get converted to benzaldehyde only. Okay, it is stopping at that particular stage because it is a function of your sulfur or quinidone to reduce the activity of the catalyst. Getting that thing? So that is one thing over here. Okay, so this is the reaction of your acid chloride in the presence of LiAlH4, and after hydrolysis it leads to the formation of your primary alcohol like this. Understanding? So whenever you are going to see a reagent like this, you eventually understand that your acid chloride is going to get converted to primary alcohol. How? We'll see that over here. Okay, so yeah, this is what we have discussed so far, and related mechanism will be taking up in a question that I am going to discuss further. Okay. So another reaction is of acid chloride is the reaction with organocadmium compound, which leads to the conversion of your acid chlorides to ketones. See, you can see your acyl chloride, that is the general reaction, reacting with your dialkyl cadmium. Okay, reacting with the dialkyl cadmium, or it could be diaryl cadmium. In the presence of dry ether leads to the formation of ketone and cadmium dichloride. Okay. So this is your general reaction, and an example has been provided to us where your benzoyl chloride is reacted with dimethyl cadmium in the presence of dry ether. Okay, and it leads to the formation of acetophenone over here. Understanding? And cadmium dichloride is released as a side product. So what is happening? Your acid chloride reacting with organocadmium compound, which are supposedly less reactive than your Grignard reagent to form ketone. Okay, so whenever you are going to see any of the reaction in which they have mentioned the substrates like this, like acid chloride is reacting with your dialkyl or diaryl cadmium in the presence of dry ether, and they have mentioned the question mark over here, so you eventually know that it is going to get converted into ketone. Understanding? So that is one thing over here. Another reaction, that is same reaction only, example are different. So you can see instead of your dialkyl cuprates like Gilman reagent, instead of your the previous that organocadmium compound you have seen, you can use Gilman reagent, that is your dialkyl cuprate. Okay, it can be also used to prepare ketone from acid chloride. So this is your acid chloride and this is your dialkyl cuprate. Okay, dialkyl cuprate, that is R2CuLi, dialkyl cuprate, CuLi. In the presence of dry tetrahydrofuran, THF stands for tetrahydrofuran. Okay, in the presence of dry tetrahydrofuran, you are going to see the formation of ketone, and these are released as a side product, that is RCu and LiCl. Correct. So this is one thing over here, and they have also shown the reaction of your acid chloride with your Grignard reagent as well, which also leads to the formation of ketone like that, and upon hydrolysis it is going to give you tertiary alcohol like that. So this is one thing that we have discussed. We have seen the reaction of your acid chloride with your organocadmium compound. Not just that, we have seen its reaction with dialkyl cuprate as well as Grignard reagent as well. Correct. So proceeding further in the same case. Okay. So your Grignard reagent and organolithium chloride, they also react with acid chloride, but the reaction does not stop at ketone stage. Okay, so that is why when you are going to see the reaction of your acid chloride with organocadmium compound, the reaction will be stopping at ketone stage only. But in the rest of the two cases that we have discussed, the reaction of your acid chloride with your dialkyl cuprate and your Grignard reagent, what is happening? The reagents will be more reactive than dialkyl cadmium will react further with ketone to form tertiary alcohol. That is one thing. Okay, so you need to keep this important point in your mind, and this can be given in place of your organocadmium. Such kind of reagents are given so as to confuse you, and you will write it over till product till ketone only, and you will not show the further reaction, and which is not correct. Okay, so yeah, it is like that. Proceeding further, now we are going to see another reaction, that is Friedel-Crafts reaction of your acid chloride, where your acid chloride, that is benzene, is reacting with benzoyl chloride is reacting with benzene in the presence of AlCl3, resulting in the formation of benzophenone like that, and HCl is released. Okay, so that is your Friedel-Crafts reaction, Friedel-Crafts acylation reaction. Okay, like that. You can see another example where your acylating agent is your acetyl chloride, and it is reacting with aromatic compound benzene in the presence of Lewis acid catalyst, that is AlCl3, resulting in the formation of this particular product and the byproduct, that is HCl again. So these are the two examples that we have discussed in Friedel-Crafts acylation reaction over here. And another reaction that you are going to see in the same case would be the halogenation of alkyl group. So in the presence of small amount of red phosphorus, what is happening? Your acid chloride having alpha hydrogen. Okay, carbon present next to your functional group is your alpha carbon, and protons related to the same are going to be alpha hydrogens. Okay, so they undergo halogenation, and like that over here you can see halogenation occurring over at alpha position to form alpha halochloride. So this is your alpha halochloride, and side product HCl is released as such. So this is your another reaction, and the another reaction that we are going to take up is your electrophilic substitution reaction of aromatic. So what is happening? Your aromatic acid chloride, they can undergo usual electrophilic substitution reaction of a benzene ring, such as halogenation, nitration, sulfonation, which we have discussed in your lower classes as well. So I want you to practice them first. If you do not understand any of them, let me know in the comment section. I'll do it. I'll make a separate video for you related to the same. Okay. So yeah, you can see over here what they have mentioned, since it is acting as a this particular group is acting as a electron withdrawing group, therefore it deactivates the benzene ring and direct the incoming group ultimately to your meta position. So you have to remember this particular part so that you do not get confused in any of the reaction that you are going to see. So that is about it. That is about all the reactions of your acid chloride. Now the question arises from the same. See, that is one question I have shown you. Another question also could be asked. So just focus over here for in this particular reaction. What is happening? Question. See, why acid chloride on reduction with your LiAlH4, it is going to give alcohol rather than aldehyde. So we have discussed over there in the chemical properties section only that in some of the reaction your conversion, see in the case of your acid chloride converting to your aldehyde. If you are seeing the reaction where Rosenmund reduction is the case, so your acid chloride will get reduced to aldehyde only. But if the case is otherwise, when it is reacting with LiAlH4, it is not going to stop at aldehyde stage only. It is going to give you alcohol like this. You can see. Okay, so this is the mechanism that I have mentioned. What is happening? There is occurring the addition of hydride ion from your LiAlH4, and it will first give aldehyde, and you can see that these are the resonating structure of your aldehyde. What is happening over here? Your carbon now, which is being more susceptible to get attacked by your hydride ion, that is acting as a nucleophile over here, and this will result in this particular product. Now what is happening? Oxygen carrying negative charge will donate its electron to this particular sigma bond, and chlorophyll, being a good living group, will get removed from here like this, and this will result in the formation of aldehyde over here. Now another hydride ion from your LiAlH4 only is going to get react with this particular carbon again, which is electrophilic. When this electron is get shifted to from your pi bond to this oxygen atom, so this will happen, and this will result in the formation of this particular product, which upon hydrolysis is going to give you your primary alcohol. So over here your H negative ion is going to act as a very powerful nucleophile. Okay, and it will further rapidly add to the aldehyde, which will to give corresponding primary alcohol. So this is the reason why your acid chloride on reduction with LiAlH4 give alcohol rather than aldehyde. And you can see the mechanism is similar, but they have mentioned it in the stepwise manner. So go through it, check it wisely, and let me know if you have not understood it well. I'll make a separate video related to the same, but you have to practice it first. Okay. So yeah, that's all about it. Thank you. Like, subscribe, and press the bell icon for more updates. Thank you.